So we'll just go ahead and get started. We have as our guest today Dr. Phil Metzger, and I'm Susan Sawyer, and welcome again. And I'll let Phil take it away. He's one of our judges for Lunabotics mining competition, and we're very, very happy to have him. And we'll be taking your questions at susan.g.sawyer, S-A-W-Y-E-R, at nasa.gov. So if you want to send in some of your questions, we'll be taking them also.
Thank you, Susan. So we're going to talk about the Lunabotics mining competition and about the rules for it. So I want to take a look at the charts. We've got, first of all, the benefits of the competition. Excavation is a necessary first step for living off the land. If we want to go to the moon or Mars or another place in space, we want to use the resources that are there and live off the land. So in most locations in space, the resources are primarily the soil, the regolith. And so excavation is the first step in getting those resources. We can then extract oxygen from the soil, build a launch and landing pad, or build a habitat. We can do radiation protection using the soil as a shield, or build roads and so forth. So mining is a very important first step. So as we're preparing to do these activities on other surfaces, we're involving the educational community, students, to through this competition to develop technologies. And we really do use what we learn in these competitions. It's a very important part of the process, having student groups come in and bring their tremendous creativity and energy. And so the judges are paying a lot of attention. We've learned quite a few things by holding these competitions. So I think that's exciting, because that means not only are you as a student group having fun and learning, but you really are contributing to the space program. So we get to see new concepts, and it also prepares the students for the workforce.
Okay, next we're going to talk about eligibility. There are some basic eligibility qualifications that you'll have to have. First is there has to be at least 2 undergraduate or graduate, and any combination of the 2 is fine, at least 2 students in and enrolled in a U.S. or international college or university. That's the first set. So the team has to have at least 2 students, undergraduate or graduate is fine. And then a team must include 1 faculty from one of the college or the university. You can do collaborations and other things, including other students, but it has to have at least 2 students and 1 faculty advisor from an accredited university. And then teams will maybe a senior design course, a robotics club, an engineering society, but it does need to be affiliated with a university and have the faculty support. This year we also required a letter from the dean of engineering or a person of authority from your university that has the authority to commit your team to a competition. And also we also required a letter from the faculty advisor. This is because we wanted to make sure that the schools knew what they were getting into. This is an intense competition. It does require travel to Kennedy Space Center in May of 2012 for a whole week. So it's a big commitment. It's not so much the financial commitment of the school, because you can raise money from other sources, but it is the commitment that they will allow you to come and travel and miss school those days at your university. So the next thing are the collaborations. I had mentioned earlier that you can have collaborations between universities, and a group can work together on a single team. We are only allowing 1 team per university campus this year, so that's a consideration you'll need to know. We really are encouraging multidisciplinary teams, and you can receive up to 10 extra points toward the Joe Cosmo Award for Excellence. If you have it's 1 point for each multidisciplinary team member. The first one does not count, so y'all have all electrical engineers, then you don't get any points. But if you have more than one, then you start counting. For the collaboration between a majority university and a U.S. minority serving institution, you also receive 10 extra points toward the Joe Cosmo Award for Excellence. So that has to be between a majority school, which is a predominantly historically white school, and a minority serving institution, and those are very specific colleges that are in the United States that are listed on the website that's listed on our website. So if you want to look at that and see if you want to collaborate with a minority serving institution, please do so, and you can add that to your registration later on. But we do have to have that by November 30th. So next is, what is a Lunabot? And I'll let you talk about that.
All right, well, a Lunabot is a robot that can be operated either telerobotically, so it's remote control from the control center, or autonomously, if you can pre-program it to perform without any remote control commands. Or it can be a combination of teleoperated and autonomy. Second of all, the robot is isolated both visually and from auditory feedback from the Mission Control Center. So the operators in the Mission Control Center can receive information through the television cameras, but you cannot have runners going back and forth to the Luna pit providing information. And the reason we're doing that is because we're trying to run it like a real operation on the moon. Mm-hmm. A Lunabot is also mobile. It has to traverse back and forth across rough terrain. So we have some rocks and some craters in the obstacle zone that have to be navigated. Additionally, a Lunabot is a mining piece of equipment. So it has to dig this black.1 aggregate, which is simulated lunar soil. It's a material we'll talk about a little bit more later, but it's in a lot of ways very much like lunar soil. Additionally, a Lunabot has to deposit this BP1 into the Luna bin at a 1/2 meter height above the simulated lunar surface. And the reason we do this is because in the scenarios we've developed so far for lunar exploration, we have to dump the soil into a processing unit, and then we use gravity and other means to feed it into the processor. And so typically there is some height that it has to be raised above the surface for dumping. Additionally, a Lunabot has a weight limit. Currently we're using 80 kilograms as our limit. And this is very important because space missions are very expensive because of the launch costs. And we have to, for realism, we have to limit the size that a Lunabot can be. And finally, it has dimensional limits. So 1.5 meters in length, 3/4 of a meter in width, and 3/4 of a meter in height. And the reason for this is, once again, you've got limits on a payload that's going in a spacecraft to the moon. So.
And this is very important this year that you know that it has been reduced. The height has been reduced from last year. It was 1.5 and now it is 0.75. So make sure you note that new requirement and build to the requirement. Okay?
All right. So what is black.1, which we call BP1? Well, it's a material that we discovered while we were doing the 2009 Desert Rats campaign. Desert Rats stands for Research and Technology Studies. And we were out in Flagstaff, Arizona, doing mining operations and mobility, driving around, and we discovered a large pile of mining tailings that were left over where they were making gravel. And Harrison Schmitt, an astronaut who walked on the moon, was actually there. And he walked over, and the material attracted some attention, and he walked over and investigated it, and he reported to us that it behaved like lunar soil. And he should know because he actually walked on the moon and walked on it. So we brought back a bucket full and we investigated it, and it actually does match the particle size distribution for lunar soil. And we put it through a battery of mechanical tests, and it actually behaves as well as our very best lunar simulated soil. So we purchased 63 tons of it and brought it back to the Kennedy Space Center, and now we use it in the Luna pit as our simulated lunar soil. And let me mention that it's not like sand. If you develop your Lunabot using sand as a material, you'll be surprised that it will not behave the same when you get into the Luna pit with BP1. BP1 has a very steep angle of repose. If you dump a bucket just enough of an angle to get the sand to flow out, the BP1 will not dump out. It'll stay in that bucket. So you have to be aware it can be very fluffy or it can be extremely compacted, and it can vary over a wide range of mechanical behaviors depending on the compaction. Okay, the Lunar Rena is the place where the competition is held. We have two sides in the Lunar Rena so that we can hold two competing Lunabots at the same time. There are 3 zones in each side of the Lunar Rena. The first zone is where the Lunabot will begin, and it's further subdivided into 4 smaller regions. And by the throw of dice, your Lunabot will be put into one of those 4 quadrants, and it will be oriented in one of the 4 compass directions. That's random, which simulates the fact that when you get on the moon, you don't have complete control over the terrain. You get what you get. So it makes you have to design to be able to turn around and navigate. The middle region on each side of the Lunar Rena is where the obstacles are located, and you have to traverse that, going around the obstacles or across them. And then in the far end of the box of the Lunar Rena is the mining zone. And you can only dig up soil from the mining area. If you bring back soil from any other area, then you would be disqualified. So you have to be careful not to dig in the wrong regions. You then have to drive back across the middle region, across the obstacles, and then deposit the BP1 into the hopper.
We just had a question actually from one of the team members from the Alabama Lunabotics. Would the robot be allowed to deploy and stay in the digging area and continuously mine, or would it have to traverse back at some point? Then dig, then transfer the regolith over something like a belt that takes it to the collector?
Well, Susan, I think you know the answer to that. I don't remember. I know we've talked about this.
I believe it does have to go back. The idea is that it would move to the digging area and then move back to the collection bin, the Luna bin. So it does have to traverse back and forth. That was one of the requirements from the beginning, that it had to move. So.
Yeah, so you can't hook a hose up to the hopper and stretch the hose across and just...
That's
right. And I think part of the reason for that is, although our Luna bin is limited in size, in a real lunar outpost, you would be driving about 1 kilometer back and forth. And so those sort of scenarios would not be realistic. So we want to try to keep it more realistic.
Very good. Okay, so we're on to the competition categories. There are 5 major categories for the competition. The on-site mining, which will take place here at Kennedy Space Center's Visitor Complex in May the 21st through the 26th of 2012. The systems engineering paper is the second required component, and the outreach project is the third required component. So the outreach project, we will go into a little more in details a little bit later, but and then we have two optional categories that you can win points in as well, and that's the slide presentation and the team spirit competition. So those are the 5 major categories. Then there are others that that are components or elements of these, but these are the main 5. Okay. So first, on the on-site mining category, we'll talk about that one for just a little bit.
Okay, so the on-site mining category, the objective is to design, build, and compete a remote controller autonomous Lunabot. And the competition is based on points. You can earn LunaPoints for the design and operational factors of your Lunabot while mining a minimum of 10 kilograms of BP1 within 10 minutes in each of 2 competition attempts. And there will be $3,000, $2,000, and $1,000 team scholarships. And there will be 30, 25, and 20 points for the 3 teams with the highest average number of LunaPoints earned. Okay?
Okay. This is different than last year. The categories are the points system is similar, but the winning the team scholarships are different this year. The grand prize will be the Joe Cosmo Award for Excellence, and we'll talk about that in a little bit, but just wanted to let you know that the prize money is divided differently this year. Okay.
All right, so the LunaPoints. Now there's been a substantial change here. This year, in each of the 2 official competition attempts, the teams will score cumulative LunaPoints. The teams ranking LunaPoints will be the average of their 2 competition attempts. So each team will be awarded 1,000 LunaPoints after passing the safety inspection and communications check. So that's, if you pass the inspections and the communications check, that's the baseline where you begin at 1,000 LunaPoints.
We had a question about that from someone, and you will just start out with 1,000 points if you pass those 2 inspections. So it's not divided in any way. You don't lose partial points for, for the communications check later on or whatever. It's just 1,000 points if you pass both, and they're both required to be able to continue to qualify.
Okay, and so then during each competition attempt, the team will earn 2 additional LunaPoints for each kilogram in excess of 10 kilograms of BP1 deposited in the Luna bin. So for example, if you deposit 110 kilograms, then you will subtract out the baseline 10 kilograms, and for the remaining 100, you will earn, divided by 10, and you'll earn 2 points for each of those 10 kilograms. That would be 200 points in that example. Okay? During each competition attempt, the team will lose 1 LunaPoint for each 50 kilobits per second of average data used. Kilobits? I think it's kilobytes per second of average data used throughout each competition attempt. The minimum of 10 kilograms of BP1 must be mined and deposited in the Luna bin competition, or you will lose the maximum 100 LunaPoints that could be lost for the communications rule. And the reason for that is because if you don't move at all and don't send any commands at all, then you have a really low bandwidth, but you can't avoid losing points for not moving or not functioning at all. So if you can move and deposit 10 kilograms, then every 50 kilobytes per second that you use in performing that will lose 1 LunaPoint. Okay. Part D, during each competition attempt, the team will lose 10 LunaPoints for each kilogram of total Lunabot mass. So for example, if you had an 80 kilogram Lunabot, you would lose 800 LunaPoints. Okay, during each competition attempt, the team will earn 100 LunaPoints if the amount of energy consumed by the Lunabot during the competition is reported to the judges after each attempt. The amount of energy consumed is not used in scoring. The only objective here is that you provide a legitimate method of measuring the energy that you consume and be able to explain that method to the judges. The reason for this is because in space exploration, the usage of energy is very important. And so we're not to the point in this competition where we're requiring you to minimize your use of energy, but we do want to move towards realism. And so we're asking the teams to have a method of measuring their energy usage. Okay, so next, during each competition attempt, the judges will award the team between 0 and 200 LunaPoints for regolith dust-tolerant design features on the Lunabot and for regolith dust-free operation. If the Lunabot has exposed mechanisms where dust could accumulate during a lunar mission and degrade the performance of life or lifetime of the mechanisms, then fewer points will be awarded in this category. If the Lunabot raises a substantial amount of airborne dust or projects it due to its operations, then fewer points will be awarded. Ideally, the Lunabot will operate in a clean manner without dust projection, and all mechanisms and moving parts will be protected from dust intrusion. The Lunabot will not be penalized for airborne dust while dumping into the Lunabin, however. And then, because this is not measured quantitatively, it's determined by the judges. It's very difficult to do quantitatively because we have multiple Lunabots in the pit, in the Lunar Rena at the same time. The judges will be evaluating in real time, and then all decisions by the judges regarding dust tolerance and dust projection will be final. And again, this is important because the moon is a very dusty environment. And in fact, dust has been identified as the #1 challenge to operations on the moon. And so again, moving towards realism, we wanted to start addressing how do we manage dust. Okay, part G, during each competition attempt, the team will earn 250 LunaPoints if the Lunabot is able to drive autonomously, no teleoperation, through the obstacle area. They might still do the mining and the depositing of the BP1 through teleoperation, but if they can just drive autonomously through the obstacle area alone, then they get 250 points. And in order to achieve this, again, you have to have the minimum of 10 kilograms deposited into the Lunabin to be eligible for those additional 250 points. And then finally, as a further degree of autonomy, if you're able not only to drive through the obstacle area, but also to do the mining and the depositing of the BP1 with full autonomy, then you'll earn an additional 500 LunaPoints for the full autonomy. And now the reason autonomy is important is because, well, while on the moon there's only a 2.7 second round trip time delay, nevertheless, the technologies that we're developing for the moon are going to be extensible for use on Mars. And on Mars you have between a 12 and 40 minute time delay, and at that amount of time delay you cannot do things with teleoperation. It has to be autonomous. And so even in lunar operations we want to move towards autonomy, and so we want to reward teams that are able to implement that in their Lunabot.
Thank you. We had a question about that, so let me just go ahead and put that out just for now from South Dakota School of Mines. For the autonomy bonus points, if a team runs fully autonomously, 500 points, do they also get the obstacle autonomy bonus points of 250 for a total of 750, or do they only get the 500? And you do get both sets of points, so you would get the whole 750 if you completely do all of everything autonomously. And there was another question is about do you have to, if you do autonomously, if you do if every trip through the obstacle course has to be totally autonomous, and it does to get those 250 points. So if you go through the obstacle course once autonomously and then back and you start manipulating your Lunabot yourself, then you do lose those 250 points. I mean, you don't lose them, but you can't gain them, earn them.
But between the two competition attempts, if you're autonomous one attempt and not the other attempt, then it would be the average of the two scores.
Yes, yes.
So that would be the only way that there would be some weighting involved,
Right, that's true.
by averaging the two different attempts.
Right.
Okay, so let's look at an example. So suppose you have a Lunabot.
Oh, I didn't get it in there. Sorry.
Okay. You have a Lunabot and it passes the inspection. So you begin with your 1,000 point baseline. Then during the mining competition you mine 110 kilograms. So we subtract the 10 kilograms, you get 2 points per kilogram. That's an additional 200 points. Your bandwidth is 50 kilobytes per second. And Susan, we're gonna have to check on this. I do believe that's probably kilobits per second.
Okay.
But we will check on that, and
Okay.
it'll probably be up on your frequently answered questions
Okay, great.
section, right?
Okay.
So, but let's say that you operate at 5,000 kilobits per second. So we divide that by 50 kilobits per second, and that's 100. So you lose 1 point for each of those units, and that's 100 points subtracted from your score. Your Lunabot mass, let's say you weigh in at 80 kilograms, and you lose 10 points per kilogram, so you lose 800 points. Next is you do report the energy consumed, and so you achieve it and you get the full 100 points for that. Next, the judges are observing you during the operation in the Lunar Rena, and you let's say that you raise a little bit of dust but not too much, and most of your components are covered up, but you do have a few things that are uncovered, and so the judges award you 150 out of the 200 points for the dust tolerant design and dust free operation. Next, during your operation, let's assume you were not able to do autonomy through the obstacle zone, so you do not get the 250 points, and you were not able to do full autonomy in the digging and the dumping of the soil, so you do not get the additional 500. And so the total points in this example would be 550. And as we said before, you have 2 competition attempts. The average of the 2 is your total score.
And those are your LunaPoints. And that is different from the Joe Cosmo Awards. The LunaPoints will be the determining factor in the first, second, and third place placement of the teams, of the winning teams. So we'll use the average of your 2 competition attempts, and you do have to do both competition attempts. That is required. And it'll be the average of your 2 sets of LunaPoints. And that will determine your placement in the Joe Cosmo Award. So if you get first place, then you get 30 points toward your Joe Cosmo Award. If you place second, you get 25 points toward the Joe Cosmo Award. And if you place third, you get 20. Now the other thing that we haven't talked about yet is if you are able to excavate any material, then you get 1 Joe Cosmo point for each kilogram that you collect and deposit, up to 10 points. So you can earn 10 points just for digging and depositing, mining. Okay. So those are all very new, and we are expecting some, frequently asked questions about that, and I've been receiving some, so we'll start going over those. And let me see if we can get a couple right now while we're talking about it. Okay, just the same as you said. The document says kilobytes per second. It is bits or bytes per second. Fairly sure it's bits, even though you keep saying bytes. So I'm sorry.
Yeah,
it's bits.
As I kept thinking about it, I thought it was probably
Okay.
bits. Small b, bits.
Small b. Okay, that's my fault then. I put
No, you had it right.
B's.
You had it right.
Oh,
I was just reading
okay.
it wrong.
Okay, well, it may be wrong in the rules too, but we'll look. Okay, so it is kilobits. Okay, and then apart from BP1 itself, have previous competitors or NASA itself determined a good material for Lunabotics competitors to practice with? Would flour, thin set, grout, concrete powder, etc. be better for testing materials than dry sand?
Yes, they would be. First of all, let me mention though, whatever you do, be safe. You don't want to breathe any of those substances, especially ones that have silica in it. These fine powders can become very easily aerosolized, and they are a health hazard. So if you're going to work with concrete powder or any of these other substances, you need to make sure that you read the safety instructions, use the proper equipment, like make sure you use a respirator that's been approved by your university or other engineering means to try to control the dust and don't expose people to breathing it. As far as the mechanics, what material behaves like BP1, BP1 has a particle size distribution that's roughly 50% sand, 50% silt, if you want to just put it in really rough terms. So if you had a mixture of sand and cement powder, that might be a pretty decent simulant. I wouldn't use just cement powder alone. I'd probably want to add some coarse material in it. Otherwise, it will be too cakey. It would compact and cake up too much.
We had a question from the Colorado School of Mines. Are there obstacles down in the BP1? And the answer to that is definitely yes. There are rocks down in the BP1. They're naturally occurring there. We can't sift 60 tons of BP1. So there are some rocks in the BP1. They are not placed there by us, and it's totally random, and we so they're not intentionally placed there by NASA, but there are some naturally occurring rocks in the BP1.
Yes, and actually that is an element of realism, because there are rocks in the lunar regolith
Right.
as well, buried and on the surface.
Mm-hmm. Then we had a question from Laurentian. Are points lost for driving over obstacles autonomously during competition? So if you are driving autonomously and you just go over the obstacles, I don't think that would be...
No, we've had teams every year drive right over the obstacles. If you can design a Lunabot that's capable of going over rocks and craters, then good for you. That's one way to solve it.
We had a question from Ben. How many teams in the past have gone fully autonomously? 0.
Right.
0. We have never had a team go fully autonomously.
But if you can do it, that would be awesome, because there are
Yeah.
companies right now that are trying to develop these capabilities. Some of our sponsors are very interested in these technologies.
Yes.
So if you show up and you've got a Lunabot with autonomy implemented, that's great. That's putting you in a great position to contribute in industry after you graduate.
Absolutely. And there will be industry partners here on site at the competition for many reasons, but they are here definitely scouting for employees. So that's our goal, is to get you employed in the space industry, or at least in an industry that is compatible and using your technology knowledge that you have gained at universities. So, okay, so then let's, let me just check and see if there's any others. Could you tell us how the judges are picked? They are picked from technical experts at NASA who deal with this on a regular basis. And each category has their own set of judges. We use systems engineers for the systems engineering paper category. We use outreach specialists to judge the outreach projects and the presentations. Same thing. We use NASA engineers and people in education that do presentations all the time to judge them. And the team spirit, we have our team spirit judges from here at KSC that do outreach all the time, and they're very enthusiastic about team spirit. So for the actual mining judges, we select people from within NASA that have experience dealing with robotics and or the lunar environment and all of these things. Plus, we also select them from academia and from industry. So that is how we have selected them in the past. So, okay. Somebody asked when we will be discussing what worked and what didn't work, and so we're going to get to that in a few minutes. Hold on just a second. Let's see. Can we move obstacles out of the way rather than moving around them? Yes.
We don't have a rule against it.
Right. You can move them out of your way if you'd like to.
Yeah, move a rock or fill in a crater, I guess.
Right.
Push the rock in the crater.
Okay. This one is from South Dakota School of Mines. It's good to be here again this year. So, the height has been reduced by half to 0.75 meters, but it looks like the collection bin is reduced in half to 0.5. Can you confirm this? Yes, that is correct. We've reduced both by half. We're going for smaller robots. We left the mass at 80 kilograms maximum, but we are encouraging you to go lower on your mass as well. This is all to help with the current technology that we're trying to develop at NASA to do more with smaller things. But we don't want to penalize teams that can't afford to go into composites, or we're not asking you to delve into that. So if you can find a way to reduce your mass, that's wonderful, but that's up to you.
Yeah, there's an emphasis right now on precursor missions, robotic missions to the moon and to Mars and elsewhere, and those would typically be smaller missions with smaller excavators. So that's what we're aiming for.
Mm-hmm. So will the competition attempts be run at the same time, back to back, or will the two competition attempts be separated by considerable time to clean the vehicle and recharge the batteries? Yes. As it stands right now, we are going to draw for the teams to compete at during their opening ceremony and during lunch, actually, on Wednesday. Depending on the number of teams that we have, we plan to start Wednesday afternoon with the actual competition. So you'll go in the same order that you went during the first round. You'll go in the same order the second round, so you'll have the exact same time between rounds, assuming each team goes the second round. If a team, if their robot breaks or whatever and they decide not to go on that second round, you could move up a little in the time, but you will definitely have time to charge your robots and clean the vehicle and even work on your vehicle. One of the changes this year is that we're leaving the Luna pits open all during the competition, so you'll be able to work on your Lunabots during the competition, stay in the air conditioning in the Luna pits, and not get so hot outside. So those are we will arrange the schedule so that your presentation time will be opposite your competition time. So it's going to be a very compacted schedule to try to get in the 2 competition attempts, but we are going for that this year. Everybody wanted it, so you've got it. That's one of the lessons learned. Everybody wanted a second chance to compete, so this year you will have that. You only get one practice though, so just letting you know. One official practice. Okay. One question from New York University Poly. What do you consider autonomy? Having 0 transfer rate or simply not touching the joystick? And are we allowed to get video back during autonomy mode for safety purposes?
Well, what we're trying to simulate is a spacecraft that's separated over a significant time delay. So we want the processing to be on board the Lunabot, not in the control center. So I believe it would be no commands going from mission control to the Lunabot.
Okay.
Correct? The Lunabot is making all of its own decisions using its own onboard computer.
Okay. And that brings me back to probably the first question we got today, actually. So let me go back and grab that one. Hold on one second. Can we use a computer to communicate to our Lunabot from inside the arena, or does it have to be an access point?
I'm not sure I understand the question.
Okay.
We will have an antenna inside the Luna pit with a hub, which will then relay your radio signal from the Lunabot back to the control center. I don't believe they will be allowed to bring another separate computer into the Lunar Rena to control it. I think all the communications will have to go through the communication network that we provide.
Right.
Did I understand the question right, do you think?
I'm not sure. If you want to send in, Adam, if you want to send in a clarification if we didn't get that question right, you will not be able to drive from inside the Lunar Rena for sure. I know that. If you're completely autonomous, I don't know where the computer would actually be.
But they can have their own computer in the mission control center.
Yes.
To originate whatever commands that go through our communication link to their Lunabot.
Right. And you do have to use our communication link. You will bring your own router again this year. That it stayed the same from last year. So you'll bring your own router, but you'll connect to the network that we provide and that we monitor. Okay. And the wood. Yeah, I think we already got that one. Okay. So let me see if there were any others real quick before we go on. Okay, even though the base footprint dimensions are fixed, can the Lunabot extend or deploy past the limits once the competition has started? Yes, you can deploy past that once it starts, and you just can't go over the 1.5 meters in height either. but you can deploy out.
Can they deploy vertically after the competition begins?
Yes, up to 1.5, but not any higher than 1.5. They can
Okay.
go from 0.75 up to 1.5.
Okay.
And then he apologizes, he missed the idea of the material to test with 50% sand, etc., and something else, and was silt?
Yeah, sand and silt. Silt would be the next finer particle size below
Okay.
sand, so you could use cement powder or some other flour, something that's very fine.
Okay.
The idea is that finer materials are more cohesive, they clump, and the clumpy behavior, the cohesive behavior, is what gives BP1 its unusual properties compared to
Okay.
regular sand.
Okay, and is starting the Lunabot remotely considered a command? And as such, would it be, will it remove eligibility for autonomy?
They would have to start it remotely
Okay.
because you need to be able to wait until mission control gives you the go-ahead to begin.
Okay.
But I think that for full autonomy, that would be the only command.
Okay.
You would also need to, of course, have the ability to stop your Lunabot in case there's an emergency. We would be able to stop it with a button inside, but you might also, I believe they should have the ability to stop it themselves if there's an emergency.
Okay. And what is the density of the lunar regolith in relation to the actual lunar gravitational field? In other words, less power is required to work on the moon, so is it addressed in the competition?
No, we're not going to require we're not going to require that anybody achieve power limits of any sort. It is true that lifting soil would only take 1/6 as much energy on the moon as it would here on Earth because the gravity is less. But we're not going to care about how much energy you actually use. All we care about is that if you have a way to measure your power or not. The density of the material in terms of kilograms per cubic meter is identical to lunar soil. The specific gravity is about 3.1 kilograms per cubic meter. But when you look at the bulk density of particles with air space between the particles, it varies over a wide range depending on how compacted it is. So it can be as fluffy as 1.2 kilograms per cubic meter all the way up to 2.4 or 2.2. So that's the variation of bulk densities. It would weigh 1/6 less on the moon than it does on Earth, but it doesn't really matter for this competition.
Okay. And are we allowed to repair the Lunabot between competition attempts? Yes, you are allowed to repair it. We'll go over that a little bit more in the lessons learned, but we are allowing you to repair, work on your robot during the competition. So yes.
Susan, I need to correct one thing I said.
Okay.
I said kilograms. It's 3.1 grams per cubic centimeter.
Okay.
And then 1.4 to 2.4, those are in grams per cubic centimeter.
Okay. And also, are we going back to the autonomy question? If we transmit a blind video signal from the Lunabot and receive the signal remotely, does that count as being autonomous?
I believe it does, yes, as long as you're not sending commands back to the vehicle. Being able to watch what your vehicle does for the ability to shut it off, to protect your hardware in an emergency, I think that's perfectly fine. The
Okay.
autonomy just means that you're not sending commands to control it.
Okay. I believe this is the clarification. Could we use a PC laptop instead of the router access point? That would allow us to offload computing to the access point instead of sending it through the measured bandwidth. And I think that would be no.
Unless the PC is a part of your Lunabot,
Okay.
right on the Lunabot, you could do the offloading as a
Okay.
part of the processing on board the vehicle.
Okay. But in any case, it does have to go through our network so that we're able to measure your commands.
Right. Yeah. No sneak paths for the communication.
Right.
But that is the intent of the communication bandwidth. If you can put computing on board your vehicle that allows your communication bandwidth to be reduced, then that is exactly the intent that we're after.
Okay.
For that sort of engineering.
Okay, so the current setup was control booth computer, measured bandwidth at Ethernet, access point, wireless link, and then robot. The question setup would be the control booth computer, measured bandwidth, Ethernet, laptop setup as access point, wireless link to the robot.
No, because that would be an extra computer in the LunaPit that is separate from the Lunabot.
Okay.
Anything that you put into the LunaPit needs to be part of your Lunabot, other than they provide the hub, right? They provide their little radio that connects to the hub. The router is not supposed to be a computer.
Okay.
It's just a router.
Okay.
Correct?
And he clarifies that basically instead of having a computer on the robot, a team could save weight by moving the laptop to the access point location still inside the Lunar Rena and communicate to the robot wirelessly. If a team had an autonomous setup, then they could offload the autonomous computing to this laptop still inside the arena, but it does not count as bandwidth. So
well, but see, anything that you send to the moon, like a computer, like a laptop, is something that you have to launch. And so it would have to be part of your weight limit for the Lunabot.
Okay.
Because otherwise you're delivering additional hardware to the moon without counting it as weight.
Okay. The other thing that we do allow in the rules is that you may have a, and I forget the name of this. Let me. You are allowed to have a point on the Lunabin to go to. What is that? A marker or
a navigation?
A navigational aid. You're allowed to attach something to the Lunabin.
Like a target.
A target.
A visual target.
Yes. Yeah. I'll find that while you're talking about the
Okay, so there's they get to put a router, they get to put a visual target, but I think anything else in the Lunar Rena is part of the Lunabot.
Right. I think so too. Okay, and why is there a final extended height restriction if actual mining would occur in an open atmosphere? Probably because ours is in a tent, is the main reason.
Was it also safety, so things don't tip over?
Tip over, maybe. Could be. We can check on that, but I think that was...
Okay, yeah. We'll check into that.
Must the voltage feed be shown as recording live during the competition, or can the report be submitted to the judges post-performance? Any information you could provide would be greatly appreciated.
That's a good question. So the issue is, do they need to have telemetered power measurement, or is it okay to read it off the Lunabot after the competition is over? I believe the way it's written right now, either is okay.
Yeah.
We haven't specified how you measure it, as long as you have a legitimate way of measuring it. So that could include just a meter physically attached to the Lunabot.
And I believe that you just have to be able to explain to the judges how you arrived at that, and legitimately arrived at that, the power usage.
Okay.
So I think it can be, we're open to ideas on that. So
measure the voltage and the current, or measure the power, or measure the torques and calculate it from the torques. There's a number of ways it could be done.
Okay. Okay, we're going to go through the next few slides kind of quickly because they're very similar to the ones that are this year. And if you have questions, please feel free to email me, questions. But for the systems engineering paper category this year, the page limit is 20. So we've increased the page limit on the paper. However, there are no appendices allowed this year. So no appendices on the systems engineering paper. The judges are only going to look at the 20 pages, so don't attach anything else. And that does not include, it says in the rules and rubrics what it does not include. It does not include the title page or the source pages, but everything else basically are the table of contents, I don't think. But no appendices. Same thing, this year you win a plaque, a $500 team scholarship for first place, and then individual certificates for first, second, and third place, and up to 20 points. Each team that submits a systems engineering paper will get the up to 20 points toward their Joe Cosmo Award for Excellence. So if you turn in a paper, you will get the points for that, up to 20, and that can be all the way down to 0. We've increased the standards this year. To get the whole set of points for each element in the systems engineering, you have to exceptionally address each of the elements in there. So make sure you really pay attention to the rubrics. In all of the other categories this year, we've increased the standards. Not that you just mention something, but it's actually addressed very well. Okay, for the outreach project, we have a page limit of 5 pages. Same, you win the plaque and $500 team scholarship for first place, and individual certificates for first, second, and third place, and up to 20 points toward the Joe Cosmo Award for Excellence. Make sure you address each element again in the rubric, and of course the higher standards this year. The live presentation, this is different this year. For the presentation and demonstration category, you will be able to present your presentation in a live, more formal setting this year. We will have judges at the competition that will actually judge your presentation, and we will be reviewing them prior to the competition, so they'll be judged on the content of the actual presentation ahead of time, but we will be judging your performance and your demonstration at the competition. So we won't know who wins this year until the award ceremony. So you have a limit of 20 minutes and then 5 additional minutes for question and answers for your presentation and demonstration. So this, along with the 2 mining competition attempts, you will have 3 official times to actually demonstrate your robot's capabilities, your Lunabot. So we'll see it 3 times in front of NASA and industry judges, and I think you'll be pleasantly surprised with that. Happy. Okay, and then the team spirit category. This we're going to do all year long this year. So you'll be judged on your actions, and most of your interactions will be with me and a few of the judges that get your questions. So be sure to be polite, and as you always are, all the teams are very good with this. But it'll be judged basically all year. It's not just a few team spirit judges at the end. It's going to be having, and I'm not out to get anybody, so don't not ask me questions because you think it's you'll get team spirit points taken off. You will not. We encourage your questions. We want you to know what you're doing, and I appreciate getting them. You'll win a plaque and $500 team scholarship for the first place, and individual certificates for first, second, and third place, and up to 15 points toward the Joe Cosmo Award for Excellence. So we're expecting great team spirit this year and a great competition. We're very excited. Okay, and then you have the bonus points categories. And we mentioned these before. The 10 bonus points for the majority school collaborating with a minority serving institution, and this has to be a designated United States minority serving institution. And there's a list of them on the website, on our website. So there's a link to the actual United States minority serving institutions. If you want to contact one and try to get a team to collaborate with you, that's up to you. You do have to do it yourself. Then you can get up to 10 bonus points for multidisciplinary teams. We have a list on the website and in the rules, I believe, of the engineering and science and math majors that you can count toward this. But if there's something that's not on there, please feel free to ask, and we can add it if we deem it as part of the STEM majors, which is STEM is science, technology, engineering, and math. Okay, and then for the up to 10 bonus points, if you don't place in the first, second, or third place in for your mining and depositing, your BP1, then you can get up to the 10 bonus points for every kilogram you deposit. Okay. And that will be an average as well. That's the average of your 2 competition attempts. So you don't get 10 for each attempt. You just get an average of your points. If you get 5 kilograms the first attempt and 7 the second attempt, you'll get 6 bonus points for that. Okay, and then the category prizes, I'm not going to read them again, but those are there. We'll be sending this presentation out to all of the teams as you register. I send it out to all the teams that have applied today. If you're on the line and didn't get it, please, you're welcome to email me, and I will be happy to send those out to you. Wait till after the webcast, though, to email me, please, for that. I don't want to confuse the questions with just requests for the presentation. The Joe Cosmo Award for Excellence, this year it will be the grand prize awarded to the team with the highest cumulative score for all of the categories. So this is a well-rounded event. We want all of the categories to count toward that. So it is the grand prize, and it will be a $5,000 team scholarship, $1,000 in travel expenses for each team member and 1 faculty advisor to attend a NASA remote test, and we don't know where that's going to be yet this year, and invitations to a NASA launch at KSC, and that is not a typo. We actually are still launching at KSC. We launch unmanned vehicles periodically, and we will invite you to one of them. So even though we're not launching shuttles anymore right now, we are definitely still doing mini launches.
The Mars Science Lab is coming up very soon. We're excited about that one, for example.
Yes. So, okay. Excuse me. The Judges Innovation Award is, you'll receive a trophy and certificates awarded to each team member, to the team with the most innovative and lunar-like design at the discretion of the judges. So do you want to talk about that a little bit?
Sure.
Yeah. Okay.
Sometimes there are features of a design that are above and beyond. They may not contribute to making it win the most points, but the design may be such of a high quality that you could actually see this device going to the moon and actually operating on the moon. Now it was Embry-Riddle in Prescott, Arizona that won it last year, and their design had a suspension. It had the way that it drove, couldn't manage the torques on the wheels, made it extremely good at mobility. It had a bucket wheel design that was very good at managing dust. And so even though it didn't get the most number of kilograms in the bin, it was a sort of a design that we could have seen actually going to the moon and operating. And so the judges wanted to be able to award a design like that with a win, even if it doesn't get the most points or the most kilograms. And so we'll be doing that again this year. We'll be looking at all the designs and looking at unique features. It could be individual features that are unique, or it could be the overall design that makes it unique. But it'll be at the discretion of the judges based on our experience in developing hardware for the moon and Mars.
Okay. You're seeing a demonstration of one of the
this is the Mars Science Lab.
Science Lab?
Yeah. With its sky crane design. We're about to see the sky crane deploy in a few moments here. That was the heat shield that just came off with the parachute. And here goes the sky crane lowering the Mars Science Lab to the surface. The purpose for this is to keep the rocket thrusters well above the surface to minimize the amount of interaction that happens between the rockets and the soil. And then it deploys, the platform tips over, thrusts for 2 more seconds, and then crashes, having completed its job. But the Mars Science Lab, now on its wheels, is able to drive away and perform science on the moon. This is going to launch very shortly now from the Kennedy Space Center.
Very good. Very good.
Yeah.
Okay, the next award is the Efficient Use of Communications Power Award. And you receive a trophy, certificates, and it's going to the team that uses the least amount of average bandwidth during the timed portion of the competition. So last year we figured it differently. So this year it's the average bandwidth during your competitions. So the attempts, and then between the competitions, the 2 attempts, that will be averaged as well. So it's the lowest average of your average. So it doesn't necessarily, you have to get the 10 kilograms to qualify for this award, but it is not linked to the most amount of regolith that you dig and deposit. So it's more about the bandwidth. Okay, and then we have a slide of the important dates, and I'm not going to read those off, but make sure you pay attention to the dates. We will not accept anything late. So make sure that you have, make sure you pay very close attention to the dates. Everything is moved up this year because it takes us a while to process everything for up to 60 teams. So we've moved everything up. Most importantly, the registration applications are due by November 30th or when 60 teams have been approved for registration. So we have not approved any registrations up to this point. We are getting ready to do that, but we wanted to give everybody an opportunity to apply, and we will select the teams from the ones that have applied and provided all the information that we've requested. So make sure you pay attention to the dates. The times are all 12 o'clock noon this year. Trying to avoid all the questions about what time does the systems engineering paper have to be turned in by. Everything is noon. Every time is noon this year. Okay, more important dates, so make sure you pay attention to that. As I said before, we're going to do the practice days. The check-in days are Monday and Tuesday up to noon. You have to be checked in at Kennedy Space Center's Visitor Complex by noon on May 22nd because of the compacted schedule to have 2 attempts for each team. That's we moved it up. And the practice days will be Monday through Wednesday, May 21st through the 23rd. And then after lunch on the 23rd, we'll go ahead and start the competition. And it'll run through Saturday and have some time for demonstrations at the end if there is time, if you don't qualify to compete during the actual competition. Okay, then there's just the rules and rubrics. We've had a revision to our rules and rubrics today, and they will be on the website today. So check back on the www.nasa.gov/Lunabotics to find those new rules. We've updated Rule 3 mostly, so make sure you check that. And we've added the dates to the dates, some extra dates to the timetable. And throughout the year, you are welcome to send me questions. I'm Susan at Susan Sawyer and my email address is there. We are recording this, so we'll be able to put this on our YouTube page, and we also have the newly revised highlights from last year that I really encourage you to go and watch the highlights film from last year, the video from last year. So, okay, for international teams, you are responsible for obtaining your own funding and U.S. visas. We cannot assist with that. We will be providing you with a letter, a team letter, inviting you to come if you're a registered participant that you can use to get your U.S. visa or apply for it. But we can't help you any beyond that. And all the letters will be sent during 1 week in February this year. We won't be sending them all year long when, you know, a member changes here and there. So it'll be a team letter all in 1 week in February. and all competition documents must be submitted in English for this event. Concurrent international competitions are encouraged. If you want to start your own in another country, we are very happy that you do that. So please feel free to, you know, we know that there's a lot of interest in other countries, and you know, we welcome that. It would not be a competition for us. It would just be an enhancement. So we appreciate that.
That's exciting.
Yeah. So for funding resources, teams are encouraged to request funds from your university, from your local space grant consortium. Each state has a space grant consortium, and you're encouraged to ask them if you need more funds. Engineering societies that you may or may not be members of, maybe this is a good time to join them. Private industry is interested in robotics, and they may be very happy to sponsor your team. And I had a question earlier today from a team that wanted to put patches on their uniforms for the competition, and they were asking if they could do that from their sponsors. And yes, you may put patches, you can do signs, you can do anything that on your Lunabot. It's perfectly okay to advertise for your sponsors. That's perfectly fine. We estimate about $10,000 to $20,000 for materials, testing, and round-trip shipping and travel to compete in this competition. We know it's you know, it's expensive, it's intensive, and time-intensive as well. So we want you to know what you're getting into before you register, or you know, commit to registering. If you have registered and you want to take your name off of the list, please let me know, because we don't want to take up a slot for someone else if you know that this is beyond you. But we do encourage you to participate, and we're looking forward to a great event this year. Some lessons learned from last year and the year before is to create a budget and a schedule to include expenses and time for travel and shipping. So make sure that you understand and schedule for things that can take extra time, like if you order a specialized part, or even a regular part that might take a long time to get in for shipping. Make sure you schedule for that, because a lot of teams last year, didn't get parts in time to use. So make sure you allow for that. Brainstorm. The more ideas, the better. So, and then once you brainstorm, try to narrow your options down as a team, but keep those backup ideas on hand. You might need to use them. Team continuity is very important. Make sure you communicate with your team and address problems as they occur. Don't let them fester and turn into bigger problems. Off-the-shelf components seem to work best. Custom-made parts take a long time to fabricate and reduces test time. So make sure you, if you're going to use a specialized, custom-made part, make sure you allow the extra time that it takes to do that. And don't make any fixtures permanent early on, because you may change your mind. So test them, test, and test again, basically is the rule around here. The properties of BP1 were very different than the properties of sand. We talked about that already, so make sure you allow for that. During testing, failure is an option, and it's okay, and it will happen. Even before the test, have an idea of what may fail and what to look for and the necessary steps to correct the problem. Pictures and video are very important to document the entire process. Keep those cameras handy. The transportation of the robot should be considered in the design phase. We had a team last year that designed their robot. They were an international team. They designed their robot to fit in their luggage. They did not have any extra shipping cost or anything. They brought it over in their luggage and reassembled it here on site and competed. So kudos to them. That was very ingenious to think of that. If you do ship it, make sure that you allow plenty of time for it to get here. So shipping it on Friday to be here on Monday is not a good idea. Make sure you ship it way as far in advance as needed to be able to arrive on time and in good shape. We do allow you to ship your robot so that it arrives no earlier than, and let me see if I put this in here. It's in the shipping, the last rule actually. It's no earlier than 5 p.m. No, I'm sorry, hold on. No earlier than May 14th. So we're allowing you a whole week for it to get here before the competition. So we will keep it in an unair conditioned area and then place it in your Luna pit for Monday morning. So it'll be here when you arrive on Monday. Okay. One team had several. Okay, the other thing is to come ready to compete as much as possible. We know that you have to set up your robot or Lunabot, you know, once you get here, but don't put off actual manufacturing, or you know, you may have to fix damaged parts, but don't try to assemble or really do major construction on your robot once you get here, because that is valuable time that you'll need to be doing other things. So one team had several parts that were spares, including the wheel assemblies and sprockets mounted to the wheels and spare scoops. These were ready to be thrown on to the robot with a maximum of 5 minutes working time should the need arrive. Spare parts and tools make repairs very fast and easy, and you'll need to think about that. This is a very harsh environment for it to be running in. Okay. This is very important. No modifications that require personal protection equipment may be made in the Luna pits. For example, there's no grinding, no welding, anything that could possibly injure anyone around you can be done in the Luna pits. So make sure you realize that. You'll either have to take it off-site, or we'll let you know if we're able to get an area here on site that you would be able to go to do that, but it is not allowed in the Luna pits. It's just too dangerous. Come ready to practice and compete. Don't count on time to do major work. We already talked about that. To get your Lunabot ready. Given the amount of teams, you will only be given one practice attempt in the Lunar Rena. We have given time in the schedule during the practice days, like during lunch, before the testing starts, before the practice attempts, that you will be able to connect online. So with your Lunabot, so you know, during the practice attempts you won't be able to test without your tether on, but during those special times you will be able to. Okay. Auditory isolation in the Mission Control Center means that teams need to consider that in their design, that they will not be able to communicate with other team members outside the Mission Control Center once the competition attempt starts. So you can't be on your cell phone, you can't be running back and forth, you have to be, there's no, it's a total isolation. We don't want to be distracting to the other team in the Mission Control Center. So. Okay, and then because of the heat this past year, we already mentioned this, but I'll mention it again. The Luna pits will remain open during the competition days so that teams may stay in the air-conditioned tent, work on their robots, and talk with guests. So we hope that we get some guests that want to come through the Luna pits, and you'll be able to talk with them and tell them about your robot a little bit and continue working on your robot if you'd like, or just relax in the air conditioning. Teams need to clean their Lunabots more thoroughly this year than they did last, and we will have stronger vacuums this year available. That was a lesson learned, that we had, our vacuums weren't really strong enough to handle all the BP1. Okay, and then very important, return shipping must be arranged prior to the competition. And teams must have their Lunabots picked up no later than 5 p.m. on Tuesday, May 29th. Any abandoned Lunabots will be discarded after this date. We are not allowed to accept them and we cannot keep them. So you must have them picked up or they will be discarded, and we would hate to do that. Okay, and then we have some links on there, and now some questions. Let me go back to my iPhone and see what all questions we have. Okay. We are losing our connection at regular intervals. Will the webcast and questions become available later? And I will send that response. Yes, we're recording, so we will provide that later. From Paul at Colorado School of Mines, what does collaboration with the minority serving institution exactly entail? And what level of collaboration is required or acceptable? You do have to have a collaboration that is meaningful. The students at the minority serving institution do need to participate with you. They can work on a particular part or a particular piece of it. They don't have to be working side by side with you because they're not always that closely in proximity to you, but they do have to be involved with the project, and the team members must be on the team roster, and we must receive all of the documentation that is required from each one of the students for them to count on your team. So if you just put on there that you are working with a minority serving institution, but you don't have any students registered on, individually from that team, from that university, then you do not get the points for that. Okay, let's see if there's any other questions here. Okay, from the University of Hawaii. Aloha. How many people can be presenting for the outreach presentation? For the presentation itself, we have not set limits on that. You can use as many of your team members as you need to. The outreach portion, there's no limit on that either. You can present to a large outreach group or a small group and do some really intensive things with them. There's no limits up or down on that. So, let's see. Is the bandwidth being tracked both information from the robot to the computer and from the computer to the robot, or is it only data from the computer to the robot? It's both.
It is both ways.
Yes, it is both ways. They track incoming and outgoing data. Okay. We have a question from India. In your rulebook under heading gameplay, rule number 8, there must be one person per 23 kilograms of mass in the Lunabot, requiring 4 people to carry the maximum allowed mass. So does it impose a constraint on team size requiring a minimum of 4 students for the maximum allowed 80 kilograms? We will provide help if you absolutely need it, but you do need to have enough students or enough team members to legitimately compete. So you would want enough students to be able to have in the control center and set up, to have some to set up the Lunabot in the Lunar Rena. If you can do both, conceivably, you could have fewer members, but you would need enough. But we will help you get into the Lunar Rena if it's needed. Does the geniusness of the design play an important role in the selection of a team for the competition? Oh, genuineness of the design. Not necessarily, because we won't have your design when you register to compete, when you apply for a registration. We will not have your design. And what is the criteria for selection of teams in the competition? We will look at your letters from your university, from your faculty advisor, and from the dean or the authority from your school, from your university. We only allow 1 per campus, 1 team for campus, and to see if you have actually competed, your past performance as well. So that will be looked at as well. And then the date of your registration will play into that, the application date. So let me see if there's any other questions. We're coming up toward the end of the webcast today. I think we've answered the ones that are here. Let me, oh, no, we haven't, sorry. Will it be possible to allow guest passes to KSC this year for external sponsors like the first year? That is something that has to be worked out with the visitor complex company that runs the visitor complex. So we will give you more information about that as we get it. We may be able to offer the special rate again this year for the ticket like we did last year, but we'll have to negotiate that. Okay, must all team members show up for the competition? This is from Laurentian. Are multiple beacons allowed on the hopper? Oh, that's a separate question. Okay, must all team members show up for the competition? No, all team members do not have to come, but you do need to send enough team members to legitimately compete at the competition. So we'll leave that up to you as to how many you'd need at the competition. And are multiple beacons allowed on the hopper? I don't know.
What does it say in the rules?
Yeah, let me look at that. Let's see. If you'll look at rule number 26, the components, they're not required to be space qualified. That's one time when they talk about the different kinds of sensors that are allowed. I'm not sure it actually says how many are allowed, but I will look at that and get back with you. We'll put it on the frequently asked questions.
If you'd like, I could keep scanning that while you look for additional questions.
Okay, sure. I think it's posted that.
Okay.
Okay. All right, this is from Morgan State University. Will there be a copy of this session as a link on the NASA website later on? It will be on our YouTube channel, and there's a link to the YouTube on the website. So you'll need to click on our regular website and then click on the left side on the YouTube channel. Any tips to reduce weight from past teams? And this is a good place for you all to talk about this on Facebook. We have a group, and the link is on our website as well. And that's a good place for you to talk amongst yourselves and you know, give each other pointers. If there's anything that you can help each other out with, you know, that's wonderful. Our Facebook link is www.facebook.com/Lunabotics. So we also have a Twitter that you're welcome to join in, and all those links are on our website.
So Susan, it says a target may be attached to the loom bin for navigation purposes only. This navigational aid must be attached during the setup time and removed afterwards during the removable time period. The mass of the navigational aid is included in the maximum Lunabot mass limit of 80 kilograms, and it must be self-powered. So it's all written in the singular, a target, a navigational aid. I suppose we could take that back as a question to think about.
Okay. Okay, and then we have another question. Can you help clarify Rule 28? Also,
Rule number 28. The Lunabot may not penetrate the BP1 surface with more force than the weight of the Lunabot before the start of each competition attempt. I think the idea is that it's allowed to sit on the surface, but it's not allowed to drive a anchor down into the surface prior to the beginning of the competition attempt. It can only sit passively on the surface until the go signal is given.
Correct. And then also, can the target on the beam emit a signal for navigational purposes? And yes, it can. Any kind of target is fine.
Okay.
Mm-hmm. The target does count toward your 80 kilograms, I believe.
Yeah.
It does count.
Yeah, it says it has to be self-powered, so that implies it can be an active target that's signaling.
Right. Can a sponsor get into the facilities to give out a demonstration of their product? We will have to take that under consideration. They may want to consider being a sponsor of the event, and we could have Delaware North Company, the ones that are hosting the event here for us at the Kennedy Space Center Visitor Complex, talk to them about being a sponsor where they could demonstrate their products. Not sure. This is a student event, so it's not really for the companies themselves to demonstrate their products, but if they were a sponsor of the event, then that would.
Yeah, I think the students are allowed to wear patches and hats and so forth and put stickers on their Lunabot. They could probably easily have handouts from the company in their region of the Luna pits. There are things like that are easily doable.
The Luna pits that we're talking about, it just occurred to me that we really haven't showed you a picture of it. You will be able to see a picture on the video that is on our YouTube channel, but you will have a 10 by 10 Luna pit, which is your area to work on your Lunabot and just kind of make your own. You can decorate it, you can hang signs, and have your work area there. We do want you to keep it neat and tidy because we will have guests going through, but we realize you are working on it, so it's not that you can't work in there. That is the whole purpose of it, but make sure you don't leave it in disarray, and especially after you leave, make sure you pick up everything that's in your Luna pit and leave it in the state in which you found it. That would be best. Okay. Does the collaboration with the minority serving institution, could it be a mutual work in the outreach area? I'm not sure. I'll have to check on that. I think it would actually have to be working on the design and building of the Lunabot. That's the purpose of the collaboration, to get minority serving institutions involved and into the design and building part. But I will check on that and get back with you about that on the frequently asked questions. Okay. And first year competition team members received a Lunabotics patch. Will they be available this year? And it's great for uniforms. And we will see. We would love to be able to provide those patches. If we get sponsorships available to pay for them and others, we would probably be able to do that, but we'll have to see. Also, if composites can be used by teams, will the use of such material be allowed? Yes, you may use composites. We just don't want, we didn't want to make it mandatory for you to use composites. If we reduce the mass of the Lunabots down too much and required them to be so much lighter this year than they were last year, then you would be forced into using composites, and that was not our intent.
Yeah.
So,
But if they do use composites and they reduce the mass, they can gain points by
Yes.
having a smaller mass penalty
right.
for their vehicle. So it would be beneficial if you can, but
Yes.
yeah, we don't want to make it to where teams cannot compete if they don't have access to that sort of technology.
Right. We tried to leave it as a level playing field as much as possible, but we are encouraging ingenuity and innovativeness and some new ideas. So go forth and do good. Okay, we are at our time limit. We thank you so much for participating with our webcast today. Thank you, and we will make this available on our YouTube page. So thank you all. Thank you, Phil, for hosting this with me, and I appreciate your expertise. And I'm not an engineer, so I really, or a physicist or any sort of the imagination. So I really appreciate all of your guidance, and we appreciate Rob Mueller for his technical expertise in getting these, helping with the rules and the judging and all of that. He's our lead judge, and Gloria Murphy, of course, for the project management. And we just thank you all and appreciate you, and thank you to the teams and the universities that are supporting these teams and the sponsors. We really appreciate it. We could not do it without you, of course, and we wanted to thank you all. Okay, have a good day. Bye-bye.